My name's Phil Holland. I'm a consultant programmer at Holland Numerics Limited, and I've been using SAS since 1981 and graphics templates since 9.1 came out. I found it very useful because of the quality of the graphs and also the fact that you can run the programs interchangeably on Unix and Windows without affecting the quality and appearance of the graphs that are produced. What I'm going to do now is show you some slides with a lot of code on. Do not try and write down all the code. More interesting is the font size I've had to use to fit the code onto a single slide, because that indicates the complexity of the code that's being generated. Okay, next slide please. I'm going to do an introduction to the statistical graphics procedures, the SG procedures, which are new in 9.2. I'm also going to create some data which will be familiar to you if you've seen any of my previous presentations, and then use that data with classic GPLOT and then also with the new SG procedures. Okay, next slide please. A lot of text there. The issue with new code like SG procedure calls or GTL is that it is very new, and people are generally quite worried about using new code, and they'd like someone to show them how to do it just to prove that it is worth the effort actually doing the learning. So what I'm going to do in this slides, in the next few slides, is just have a quick look at each of the procedures just to show you what it can do. It's not going to show you everything it can do, but it'll show you something which will hopefully be useful. And using the same data, you can then compare the different procedures to see which one is most suitable for what you want to do. Because if you're doing graphics, you probably use PROC SGPLOT. That's the reason for producing graphs with the same data with GPLOT, so you can make a direct comparison between the classic methods and the new SG procedures. Okay, next slide please. Standard piece of code, it is probably fairly familiar now. The predict greater than 400 is intended to make it slightly less uniform. I've used visitnum as a standard name to make it comfortable for clinical programmers, but it is actually a sales one, and I've kept in the price values just to show its origins as much as anything else. Okay, thank you. Next slide. This is a modification which I needed to do to make it work with PROC SGPLOT, and basically what I've done is read in the data and changed the price variable to val, and then use that to generate two values for each price, so on separate records, one with the standard error added and the other with the standard error subtracted. And then we're going to draw a line through the midpoint, which will effectively be the original value. It's just a fancy trick that you have to do with GPLOT to make all the data fit into the same data set. I've also slightly shifted the visitnum values for the bed and desk data to make sure that the three values that are in there are offset so you can see the original points. You'll see that technique used in the other data that's coming along. And next slide please. The ODS data, we don't need to do any of this fancy double record business. It can be put into the same record and actually have new values calculated for the price plus the standard error and the price subtracted with the standard error subtracted. Again, we're shifting the visitnum just to make sure that the graph is a little bit clearer. And the other item that we do need to do, the count, needs to be placed as a character value. Okay, next slide please. This is the GPLOT code. you can see just about that there are 3 lines at each point, and because they've been offset, the error bars are not standing on top of each other. And it is a very simple graph. I haven't done any fancy G option statements. There is an ODS RTF statement at the top, which is to wrap the whole of the graph into an RTF file, and that will be done for all the other graphs as well. Remember, we had 2 different records for each point. The high-load TJ interpolation is the T is for top and bottom, so it actually puts little hats, and the J is to join the middle value. Okay, next slide, please. To do a similar graph, and I've only picked one value for this particular one to make it a little bit clearer, and this is with sgplot. What you can do is do a similar sort of statements to the statements that you would have in a template. And instead of having to write plot, it's just series or scatter. The parameters are pretty much the same. And then we've added a couple of reference lines which are not wonderfully clear on that graph, but they're at 1100 and 1300. I've used ODS graphics on and off. You don't actually need to do that with sgplot, but it does allow you on that statement to put in an extra option which specifies the type of file you're going to be producing. Okay, next please. What I didn't point out, and you'll see in subsequent ones, there's an extra parameter on the sgplot statement which is temple out equals, and then in quotes, a program name. This is the program that's generated from within sgplot, and it's a template. So you can do all your fancy programming in sgplot, and then allow it to do the writing of all the template code, and then you can just tidy it up, maybe put in some dynamic values to make it more general. So it hopefully save you a bit of typing at the end. Now you're going to see generated SAS code for the other procedures as well, and you notice this is a relatively large font because it's a relatively simple template. As we get further in, you'll see the font size will drop quite dramatically, and that's because there will be a lot of code there which is generated for relatively small amount of code that you type in originally. Okay, next please. Right, sgpanel is effectively sgplot, but it allows you to make a block of identical graphs by a group variable. So instead of doing by group variable, you could actually do it using the panel by statement in sgpanel, and it will add the name of the group variable at the top of each graph. You can change that with formatting, but generally you want to do this for maybe patient profiles. So you're looking at the same data for a large number of patients. By default, it will give a 2x2 grid. If you happen to have, in this case, 5 graphs, what it will do, it will produce a second graph with just one in a 2x2 grid. So you don't have to do anything special. If you've got 150 patients and you're doing them in blocks of, I don't know, maybe 4x2 on a sheet, it will divide up 150 patients into blocks of 8 without you having to do any more, which I think is really good. And the thoughts of what I had to do in PROC SGPLOT and PROC SGREPLAY to do that just fills me with horror. The other key items, again, we've got this temple out statement on the PROC SGPANEL, and you'll see the code that's generated next. But other than that, the individual series and scatter statements are exactly the same as they were in the previous graph. Thank you. Next slide. And you see the font has dropped somewhat. The key part is about a third of the way down. You have label gridded, which is the general layout of the graph itself, and then inside layout data panel, and it comes up with columns 2, rows 2 on about the third line of the data panel, which shows the default for the grid itself. I think that's probably something that you'll need to pick up and download and look in detail after this. I'm not going to expect you to read through all that in one go. Okay, next slide please. SGSCATTER is a slightly different angle on the data panel because you can produce graphs of different sets of variables. Now, I've used a compare, but there are some other options which do slightly different things. But this one, the compare is putting similar sets of graphs with the same axis for the x-axis, so you can actually do a comparison. In fact, the comparison is not really going to be very obvious because each one is the original, the upper error level and the lower error level, so you would expect them to be very similar shapes anyway. Again, we're putting in the x value as visit num, but the y value is in brackets with the different variables that you want to put into the comparison. So if you wanted to do, say, blood pressure, so systolic and diastolic blood pressure in separate graphs on top of each other for comparison, that may be appropriate. Okay, next graph. Next. And again, the font has dropped again. The key there is it's using a lattice layout, but it's not specifying more than the lattice will contain overlays, and there are 3 overlays because we've specified 3 graphs that we're going to produce. Okay, next please. Right, slightly bigger font, but this is actually going to do it from the graphics template angle first, and then push it back into the graph using PROC SGRENDER. This is an alternative. The SGRENDER is an alternative to the data null step, which could be used instead. And we're using the marker characters to put some counts of numbers, which is why we needed that character value. Mentioned C count, which was in the original data, and that's going to be placed at the bottom of the graph. And then there's, in the lattice statement, it's specifying how many columns, how many rows, and the row weights, and column data range equals union, all to specify that the x-axis will be identical. Okay, next please. And that's the code to actually call it with SGRENDER, and this is the graph that's produced, again with a slightly offset x value, just to make sure that you can see all the error bars clearly. And underneath there's the counts of the patients that are contributing to each point. Okay, next slide please. Okay, conclusions. We've all fought with PROC GPLOT and PROC GChart over the years, and they do produce very good graphs, but they're not necessarily easy to control. You have to do a lot of specifying of the axes to make sure that they look sensible. Whereas I haven't pointed it out as we've gone along, but all the axes have produced results which feel right. Not too much data, and so you don't get this horrible overlapping of text. And in fact, it's very difficult to get the SG procedures to make the axes overlap values. You can use the SG panel and SGPLOT to produce combined graphs which are difficult to create with GPLOT and GChart. And the SG panel and scatter have the ability to produce large numbers of graphs almost automatically. Whereas PROC GReplay, I would not even attempt for 150 patients. And finally, the SGRENDER, you can use it to take your templates and produce a graph just by putting a data step into them with a few parameters, depending on how your template is set up. Okay, next slide. So all the code that you've seen in this presentation you can download from the website, and that's my contact details in case you have any questions. Next slide, please. And these are the two existing books I have. There's actually a book coming out at the end of 2011, assuming I can finish writing it by then, on GTL and other ODS templates. Okay, thank you very much.